video we are going to discuss about the superposition theorem, and obviously this video is dependent upon the only independent sources. Okay, so this is ESE 101 syllabus, first semester syllabus. So what is superposition theorem exactly states? It states that in a linear active bilateral network containing more than one dependent or independent sources, the resultant current in any element is the algebraic sum of the current that would be produced by each independent source acting alone, and all here you have to add and all other independent sources being replaced by their respective internal resistance. This is a quite a huge statement, but actually the technique is quite easy. Okay, so it means that a linear active bilateral network means it is a we are applying this theorem. In this video we are applying this theorem on the linear active bilateral network, that is the in a resistive circuit. That means there is some resistances and some voltage source and current source, that is a dependent source. Here we are not going to discuss about the dependent source, we are discuss about the independent source. So you can write it as more than one independent sources only. So if a circuit containing linear active bilateral elements, that is the resistances and the current and voltage source, that must be an independent source, then the resultant currents means if you have to find out the current, you can say in this example, if you are taking this circuit as an example. So if we are going to find out the current through this R4 resistance, that means this is the RL load resistance, then and by the superposition theorem what should we do? We should, that is the resultant current in any element, that is the why resultant current, because in this load resistance the some current is supplied by this voltage source and some current is supplied by this current source. Okay, so that means that's why the resultant current, it means that in this load resistance, if voltage source are supply the current I1 in the downward direction, and if the current source is supply the current in the upward direction, then the resultant current is nothing but the I2 minus I1, sorry, I1 minus I2 or I2 minus I1. It is dependent upon which one is greater, that is in this case I1 greater than I2 and in this case I2 greater than I1. Okay, that means, and you have to, if I1 greater than I2, then you must give the arrow after the result, that is the resultant current, and the current direction is downward because I1 is greater than I2. And if in this case the direction of the arrow is upward because the I2 is greater than I1, that means the upward current is more than the downward current. Now what should we do? That is the of the current that would be reproduced by each independent source acting around, means here two sources are there in this diagram, two sources are there, means we have to find out first if I1 current is for the I4, you can say that, because in R4 we can say that the current flowing through R4 is I4 dash is the current supplied by the voltage source. Then what should we do? We should replace the current source. That means we should replace the current source. That means we have to omit this current source. How we can omit this current source? That means current source is, what should we do? We should replace current source by make it open circuit, that is it has infinite resistance, we can say. And if there is a voltage source, means when you are considering the current source only, then we should replace this voltage source, and as we replace the voltage source, we should replace the voltage source by the short circuit, that is the R is equal to 0. Okay, that is the internal resistances of the current and voltage source. That means, so first step, what should we do? The current source is replaced, that means current source is omitted. So here this is the short circuit, this is the open circuit path because it is a current source. So as it is open circuit path, then we can obviously neglect this path, that's why we are not considering this path. So for the V, this is the positive terminal, this is the negative terminal of the V, so obviously current will flow from the positive to negative. So the direction of current in this R4 through the V is I4 dash. So this is the I4 dash we are getting, and it is obviously downward. Now again, now considering the current supply by the this current source, now we have to omit this voltage source, means we have to replace the voltage source. How we can replace the voltage source? We can we can make the voltage source short circuited. So as the direction of the current source is upward, so the current flowing through this R4 is I4 dash double dash, and it is obviously in downward direction. So the resultant current through the R4 is I4 dash is downward, I4 double dash is also downward. So the resultant current, that is I4, is equal to I4 dash plus I4 double dash. This is the summarize of this theorem. Now go to the next page. Now we go through some example. There is a type 1, only current sources are there. So it means that only current sources are there, and we have to find out the current through the 8 ohm resistance. Means we have to find this, we can make it red because it is a load resistance. It means we have to find out how much current is supplied by the supply through this 8 ohm resistance. What should we do? Now we should replace one by one. That means some current, now it is upward direction, so we can say that current flowing through this up direction is I dash. Okay, now we have to replace this one. So first step is you have to write down when 5 ampere is acting alone. Now what is the circuit diagram? The circuit diagram is like this. This is your 5 ampere which is acting alone. Then take 12 ohm as it is. Then here it is 8 ohm. We have to find the 8 ohm current through 8 ohm. This is 30 ohm, and we have to make this open because this is a current source, and we can consider the internal resistance of the current source is the infinite resistance, so we can make it open. So we are not considering this part because this is an open circuit. So this part we are not considering, so we can omit this part. Okay, now the circuit is look like this. Now for this 8 ohm, this is 8 ohm, this is 12 ohm, and this is 30 ohm. So and this is the 5 ampere current source. That means if we are considering the current which is flowing over here is I dash. Now what is the, we can simplify the circuit in this way because you see that 8 ohm and 30 ohm are in series. So make them in series. So here as it is 12 ohm is present, and we can make it as it is a 38 ohm, and this is a 12 ohm, this is a 5 ohm. Now this is very much easier to find the current through 38 ohm resistance, that is also I dash. So 8 ohm and 30 ohm both are in series. So whatever the current, this is 8 ohm, this is 30 ohm, whatever the current flowing through the this 8 ohm, that current should flow through the 30 ohm because in the line the current remains same. So 8 ohm and 30 ohm, that means the 38 ohm have the same current as it is flowing in the through the 8 ohm. So here two resistances are in parallel. So now what is current division rule? That means here it is you have a current source that, and you have a resistance over here, that is a R1, and here it is a resistance of R2. Now what is the current through R1? If it is I2, then what is the current through I2? If it is the I, then I2 is equal to the total current I into R1, the resistance which we don't have to consider in the current branch, by R1 by R1 plus R2. Like this, if we are going to find out the current through R1, that is the I1, what should we do? So I1 should be I, that is the total current, into, we have to consider the resistance which is not in our question, that is the where we should not find the current, that is the R2 by R1 plus R2. Now we have to again apply this rule. So applying CDS, that is the current division rule, we get we get the current through 38 ohm is, that is the 5 ampere is the total current, that is the I dash is nothing but the 5 ampere is the total current into 12 ohm, because we have to find the current through 38 ohm. So instead of that we are considering the 12 ohm as numerator and denominator is 12 plus 38. That means it is the 60 by 50. That means it is 5 by 6, sorry, 6 by 5, not 5 by 6, it is 6 by 5. That is the 1.2 ampere, and we have to apply, we have to give this arrow in this direction. That means the current is flowing from left to right. Now considering, so for this 8 ohm resistance, if if only 5 ampere current source is there, then the current flowing through the 8 ohm resistance is 1.2 ampere. Now considering this 25 ampere current source. So now if the direction of the current source is in this direction, so we can say that the current which is supplied by the battery through this uh, 8 ohm resistance is like this. Okay, that means that means if we, when you have to write, when 25 ampere is acting alone, what is the circuit diagram? This is the 8 ohm resistance, this is the 12 ohm resistance, this is your 30 ohm resistance, and this is your 25 ampere current source. Got it? Because this part is open circuited, because we have to replace the current source as it has an internal resistance of infinite resistance. So this is your 25 ampere, this is your 30 ohm, this is your 8 ohm, and this is your 12 ohm. Now we can again simplify this thing. So this become 8 and 12 is in series, so this is the 20 ohm, and again this is 30 ohm, as it is you can write 30 ohm, and this is your 25 ampere, and the direction of current is, if you instead of here, if we draw if we draw this, if we place this resistance over here, then the resistance is like this. It means the current supply by this current source is in this direction, so it is become I double dash. So again we are applying the current division rule. So I double dash become the total current, that is the 25, into, consider the resistance where we don't have to find out the current, that is the 30, divided by the, here resistance was 20, 30 plus 20, that means 25 into 30 by 50, that is the 750 by 50, 15 ampere, and which is also in this, that is the left to right. So I double dash is left to right, I dash is left to right. So the total current supplied by the through 8 ohm resistance, you have to write it, the current through 8 ohm is I is equal to I dash plus I double dash, that means 1.2 plus 15, that is the 16.2 ampere. Okay, I think you got it. Now go to the second question. Second question is, or if all are the voltage sources, that is the, we are considering all the sources which is voltage source, that means voltage source is replaced by the short circuit. Okay, now what should we do? First step is step 1, that is consider the 40 volt is acting alone. So when 40 volt is acting alone, so what should we do? That is, we have to draw this diagram. So this is short circuited because it is a voltage source. This is 10 ohm, this is 2 ohm, and this is short circuited, and here it is a 40 volt. Okay. So what is the circuit? The circuit is like this. So this is 40 volt, this is your 5 ohm, this is your 10 ohm, this is your 2 ohm. Okay. Now, now the current through 2 ohm resistance. Okay. Now you have to write the direction of the current. That is the, for 40 volt the direction of the current is, if it is I dash. Okay. So to find out I dash, so 40 volt is supplying the current I, and that is divided from here. Here I dash is going through this 2 ohm and some current is flowing through this 10 ohm. Okay. So we don't consider that the current which is flowing in 10 ohm, that is not in our business. So it means we have to find the I first. If we have to find the I first, then we can easily apply the current division rule to get the total current. So what is I? Now to find I, that means I is equal to V by R. What is V? V is nothing but the 40. And what is R? R means the R equivalent. What is R equivalent? So 10, so 2 and 10 are in parallel, and then whatever the resultant of these two are, that is in series with the 5. So 5 is series plus 10 parallel to, that means 40 divided by 5 plus 10 parallel to means 1.1 by 10 plus 1 by 1 by 10 plus 1 by 2, and its reciprocal, that means it becomes, it will come out 1.67. So it is the 1.67. So what is the I? That is the 40 by 5, 6.67, 6.67, that is nothing but the 6 ampere. Okay, that means the current supplied by the voltage source is 6 ampere. Now the resultant of is 2 and 10 is 1.67. So what is the current? The current, now we can easily apply the current division rule. Okay. Now, so these two are in parallel. So the current supply by these batteries I is 6 ampere, that is the 6 ampere current is flowing through it. Now applying current division rule, what is the current? That is the I dash become 6, that is the total current, into the, we are find the current through 2 ohm, and 2 and 10 are in parallel. So here it is at, it is a 6 ampere voltage source, current source, and here it is a 10 ohm resistance, and it is a 2 ohm resistance. 10 to, we have to find out the current through 2 ohm, that is I dash. So I dash becomes 6, the total current 6 into 10 by 10 plus 2, that is the 12 is the 5 ampere, that is the 5 ampere current is supplied by this 40 volt. When 40 volt is acting alone, the current is 5 ampere. This is, and it is from left to right. You should keep this on your mind. This is the most important thing. Depending upon this, you can find out the resultant current. Now second part is when 20 volt is acting alone. So when 20 volt is acting alone, what should we do? We should again draw the circuit in the similar way. This becomes shorted, this becomes shorted. So this is your 5 ohm, this is 20 volt, this is your short circuited, this is your 10 ohm, and this is your 2 ohm, and this voltage source 10 volt is short circuited. Now this is your 2 ohm, this is your 10 ohm, this is your 5 ohm, and this is your 20 volt. Now the current which is supplied by this is I. Okay, then we can find the I, and then here some current is flowing through it and some current is flowing over here. So this is the I double dash. You have to means you have to find out the I double dash. To find I double dash, again we have to find I. So what is I? So to find I is equal to V by R. So what is V means V by R equivalent. So what is V by R equivalent? V is given, that is the 20 volt. What is R equivalent? This is nothing but the same. 5, 10 and 2 are parallel and then they are connected in series. So that means the 5 plus again 10 parallel to again 10 and 2 are parallel, and then this is the 5 and that resistance are in series. That is the 20 by 6.67. That means here if it is 6 ampere, then it is 3 ampere. So the current supply by this for 20 volt is the 3 ampere. Now again apply CDS, current division rule, for to find I double dash. I double dash is what? The total current 3 ampere which is flying through it. That's the current into again 2 and 10 are in again parallel. You have to find out the current through 2. So 10 become numerator and 10 plus 2 become denominator. So 3 that means 10 by 4, that means the 2.5 ampere, and the direction of the current is, that is the right to left, that is the right to left. If you make it right left to right, it becomes minus 2.5 ampere, and then we can make it right, left to right. Got it? Now the third part. Third part is when 10 volt is acting alone. It's a simple part because here 5 again 5 ohm is here, 220 volt is short, 40 volt is short, here it is the 10 ohm, and here it is your 2 ohm, and this is your 10 volt battery. You must keep the direction of the positive and negative plate. So this is your negative, this is a positive plate. So this is the I. So this is your I triple dash. Okay, because here the current which is now you cannot say I triple dash. So the battery is supplying some current and the current is divided into in this direction. So if we are simplify this circuit, this is 2 ohm, this is 10 ohm, and this is the 5 ohm. Now we can simplify the circuit. Then you apply, if you want current division rule, then you can apply. So 5 and 10 are in series, sorry, parallel. So 1 by 5 plus 1 by 10 and make them reciprocal. That means the that is the its equivalent resistance is, I think, 2 plus 1 3, the 3.33 ohm inverse, make one inverse 3.33 ohm. So what is that? The actual circuit diagram, the actual circuit diagram is 3.33 ohm is the equivalent resistance of 5 and 10. This is 2 ohm and this is 10 volt. Here I write 10 volt. Now the 10 volt is applying I3 current, because whatever the current which is flowing through 3.33 ampere ohm, that current is also flowing through the 2 ohm. So I triple dash, we don't use the CDS because it is a 2 and 3.33 are in series and there is no other resistances. So I3 is the 10 by V by R, 10 by 3.33 plus 2, that means the 10 by 5.33 and it become 1.88 ampere, that is also in left to right. So what is the I? The resultant current I become I dash plus I double dash plus of I triple dash, and all are in the, this is the 5 ohm 5 ampere left to right, minus 2.5 ampere left to right, minus 1.88 ampere, sorry 1.88 ampere left to right. So it become 5 plus of minus 2.5 plus of 1.88, because to make 2.5 in the same direction we can make it minus 2.5. So it become 2.5 plus 1.88, that is the 4.38 ampere, and obviously the direction of current is left to right. I think you got this numerical. This is very simple numerical. So just superposition theorem is based basically for your class, it is basically it is based on the current division rule. Maximum you have to apply the current division rule. In a few cases you have to apply the KCL and KVL. Now go to the next question. That is the here voltage and current source all are here. Now go to the this question first. Okay, skip this question, because you if you solve this one, then you can easily find means solve any superposition problem. Okay, now what is the problem? Problem is here 10 ampere current source is there, 10 ohm, 30 ohm, 5 ohm, 20 ohm and 100 volt is there. Find the current through 10 ohm resistances. So here it is your 10 ohm resistance and this is the load resistance. You have to find out the current through it. Now first what should you do? Again the same thing. First is when 10 ampere is acting alone. Here it is the 10 ampere. Okay. So when 10 ampere is acting alone. So what is the circuit diagram? So this so when 10 ampere is acting alone, then okay, you just take first you take 100 ohm is acting alone, then it should be better to solve it. Okay, so you can say that when 100 volt is acting alone, then what is the circuit diagram? So make this remove. So here it is the 5 ohm, here it is the 10 ohm, here again 20 ohm, here it is 30 ohm, and it is the 100 volt. So this is your 100 volt, this is your 30 ohm, this is your 10 ohm, this is your 20 ohm, and this is your 5 ohm, and you have to make this open. Now you can easily so 10 and 2 are in series, so we can simplify this in such a way that these 2 and 5 5 and 10 become in series. So make them added and this become 15 ohm. This become, we can write it as 10 plus 5 is equal to 15 ohm. Now we can again you have to re-simplify it. So 15 and 20 are in series, sorry, parallel. So the resultant circuit is, this is your 30 ohm, this is your 100 volt, and this is your the 15 parallel 20. So what is 15 parallel 20? Is it become 1 by 15 plus 1 by 20 and reciprocal. So it become, if we solve it, it becomes 60 by 7. So this is the 60 by 7 ohm is the this equivalent resistance of the 15 and 20 parallel. So this become 30. It is make as it is 100 volt. Now what is I? So I, which is supplied by it, is nothing but the I is equal to V by R. So V is the 100 volt and R is the 30 plus 60 by 7. That means 270 by 100 into 7 by, it is the 270, that means 70 by 27 ampere. Okay, 70 by 27 ampere. Now what should we do? The current which flow through 10 ohm, the current which flow in the if before that, means we are taking this 15 ohm. So what is the actual circuit diagram? This is the 10, this is the 5, this is the 20, this is 20, and this is 30, and this is your 100 volt. This is the actual circuit. Then that become this, and this become this. So this is the 10, this is the 5. Okay, this is the 20, this is 30, and this is 100 volt. That was the circuit. So whatever the current which is flowing through that 5 ohm, that current is also flow through the 10 ohm. Okay, and whatever the current which is flowing through 5 and 10 ohm, that current is flowing through the 15 ohm. That means the 15 ohm and 20 ohm are in parallel. So whatever the current flowing through the 5 ohm, that current is flowing through the 10 ohm, and that current is also flowing through the 15 ohm. And what is the direction of the current? The direction of the current is in the downward direction, because you can see that the current supply by the battery is I dash. So what is I dash? I dash become the total current I into, that is the 50 and 20 are in parallel. So 20 by 15, 20 plus 15. What is the I? I become 70 by 27 into 20 by 35. So 35 to the 70. So 40 by 27, that is nothing but the 1.48 ampere, and this is the direction is right to left. This is the most important thing. Now second part, and it is the easiest part, that is the when 10 ohm is 10 ampere is acting alone. Second part is when 10 ampere is acting alone. Now this is your 10 ampere current source, this is your 5 ohm resistance, and this is your 10 ohm resistance through which we have to find out the current. This is your 20 ohm, this is your 30 ohm, and this is your 100 volt, which is short circuited because it is a voltage source. So this is 30 ohm, this is 20 ohm, this is 10 ohm, and this is 5 ohm. Okay, now so 10 to 20, 30 and 20 are in parallel. So redraw this circuit means you have to more simplify this circuit more. So this become 5 ohm, this become 10 ohm, and this become 20 and 30 are in series, parallel. So the resultant of 1 by 20 plus 1 by 30 and its reciprocal. LCM is 60. So 23 is 60 and 30 2 is 60, means 5 by 60, means reciprocal is 60 by 5, that is the 12 ohm is your equivalent resistance. So it is the 12 ohm. Now this is a 12 ohm. Now this is your 12 ohm, this is your um, this is your 10 ohm, this is your 5 ohm, and the current source is 10 ampere. I think you got what should we do in the next stage. So 10 and 12 are in the same, and the direction of current is I double dash. So whatever so 10 and 12 are in series. So again read out this circuit. So this is your 10 ohm, 10 ampere, this is your 5 ohm, and this is your 22 ohm. So whatever the current which is flowing through this 10 ohm, same current is flowing through 12 ohm, and as they are in series, so that current is also flowing through the 22 ohm. Now apply, so this is 10 ampere, now apply CDS, that is the current division rule, that is the total current I, that is 10 ampere into, we have to find the current I double dash, that is the left to right, is nothing but the, so you consider numerator is 5, denominator is 5 plus 22, that is the 50 by 27, that is the 1.87 ampere, and the direction is left to right. So here it is the right to left, here it is the left to right. So what is the resultant current? Here the, so I dash is 1.48, left, sorry, right to left, it becomes minus 1.48 if we consider it as left to right. Okay, now I, which is flowing through this 10 ohm, is nothing but the I dash plus I double dash. I dash is minus 1.48 plus I double dash is 1.87, so this become 0.37 ampere, and the direction is from left to right. So the current flowing through the 10 ohm resistance is 0.37 ampere, and which is flowing through the left to right. So the type 3 question is nothing but a circuit containing both the current and voltage source. Okay, this is your homework, you can solve it in your home. If you face any problem, you can comment me and I will help you. This is the, all of the voltage source means the circuit containing voltage source, this is the circuit containing the only current source. So these three types of numerical, if you solve it, then you can easily solve any kind of numerical. So keep visiting my channel and do more numericals, practice more numerical to make it simple and make your life shining. All the best. See you in the next video.